Okay, so welcome back from spring break. I hope that everybody had a very nice week off and that you enjoyed yourself very much. Through the file transfer window, I did share 2 items with you. They're Trig Identity notes. I also kmailed these out to you as well. So if you already printed them earlier today, then you don't need to print them again. But I just wanted to share them with you twice. So through kmail, they're in an attachment, and then I also put them through in the file transfer window. And these notes are going to be super helpful this unit, so that way you can use them and you don't have to have them all memorized necessarily. So let's try a few of these together. Our essential question for this week, we're in week 11. It is, what is the difference between an identity and an equation? There's a big difference between the two, and we're actually going to cover this answer at the very beginning of the session today. So in this lesson, first let's talk about an identity versus an equation. So let me give you an example. If I said 2x equals 4, that's an equation because it has one answer, x equals 2. So equations have one answer. Identities are true for any value that we're going to plug in for the variable. So that's the main difference. Equations have one answer. Identities have multiple, many different answers. We can check this by solving the equation just like we just did here. If you get a variable on both sides, it's considered an identity. But if you get a variable equals a number, like here x equals 2, then it's just an equation. So again, if we have variables on both sides, it's an identity. If we have a variable equaling a number, like we did up here in our example, then it's just an equation. So we're definitely going to be using this Trig Identities handout this unit. Nicole, were you able to print that out? Okay, fabulous. So this unit is all about proving identities, well, doing some proofs using the identities. So here's just a quick snippet from the online lesson for 4.1. It says if you are asked to prove a trigonometric identity, it is not sufficient just to give an example. So for instance, if I'm trying to prove that this statement is true, I can't just pick one value for x, plug it in, and say, well, when I plugged in pi over 4, it gave me a 1, so therefore I just proved that that's true. That's not correct. It's not a proof. When we prove something, we have to prove that it's true for all cases. That means for any value that I could pick for x. So we're going to go over the steps for how to do that on the next slide. So first I want to start with these. They're called the Pythagorean Identities. So let's write them down, and I want to show you how they get the 3 Pythagorean identities that are on your chart. The one that I passed out that you have printed out in front of you. So let's start with this one on the left. Let me give you a minute to copy that down. Okay, so this one is considered your basic Pythagorean theorem identity. So this is what we'll call number 1, is the original right here. Let's divide all 3 sides by cosine squared theta. And now let's simplify and let's see what we have. There we go, sorry about that. Okay, so cosine squared theta divided by cosine squared theta would give us a 1. Here I get sine squared theta over cosine squared theta. And then 1 over cosine is the same as secant, so I can change that to secant squared. And then the last thing I can do is right here. If I'm looking on my identity sheet, sine squared theta over cosine squared theta is the same as tangent squared theta, or sine divided by cosine is tangent. So I can replace that middle portion. Okay, that was weird. I can replace this middle section with tangent squared theta. So here is another trig identity. So we'll call this one number 2. So number 1 was our original cosine squared theta plus sine squared theta equals 1. Number 2 is 1 plus tangent squared theta equals secant squared theta. And then our third one, we're going to start with the same basic identity, but this time let's divide all 3 sides by sine squared theta. So this time, cosine over sine, when cosine's on top, we can rewrite that as cotangent. And again, that's just from your trig identity sheet. So keep your trig identity sheet handy. I know I gave you 2 of them. I like different parts of each of them for different reasons. I'll show you why in just a minute. Sine squared theta over sine squared theta is 1. And 1 divided by sine squared theta, we can say that that's cosecant. So this would be number 3. All 3 of these are on your chart. So let me pull up that chart real fast so I can show you the parts that I really want you to highlight here. Okay, let me see if it's going to let me take a picture. Oh, that's cool. Okay, awesome. Can you see that okay, where it says Pythagorean theorem or Pythagorean identities? Does that show up for you on the screen? I'm not sure, so that's why I'm asking. I took a picture and it's supposed to be what you're seeing now is the picture. So right in this section are your 3 Pythagorean identities. We just proved all 3 of these together on the last slide. And the other main one I want you to have highlighted today is we're going to use the quotient identities also. Okay, so have that printed out. Write on those, highlight those. So how do we prove an identity? Well, a couple things. If we're asked to prove an identity like this, what should our first step be? There's a couple key things that we're going to point out. To solve an identity, we're going to start with just one side of the equation. When we pick one side of the equation, we're going to work with that one side of the equation and try and make it look like the other side of the equation. The key, here's kind of a good rule of thumb. It's always a good idea to start with the harder side. So if you have one side that's longer looking than the other side, we're always going to start with the harder, more complex side. So if we're going to start with the right-hand side, we're going to use identities that we already know plus some basic algebra to rewrite it until it looks like the other side. It's kind of what we talked about earlier. We're going to use our algebra skills like factoring, simplifying fractions, common denominators, all those things to be able to rewrite them. And we're going to have to use the identities that we already know to help us. So keep the chart handy that I gave you because we can substitute those in at any time. So we're going to practice some together today. So I'm going to lock the room at this point, not allowing any new students to enter. So this was from your 4.1 checkup. I'm just going to do a couple questions with you guys because I want to make sure that you are really understanding them. So number 6 said, prove the identities in questions 6 through 8 by filling in the calculation column. So here's the part that they want us to do. Yes, Nicole, if you have a question, can you type it in? I'm just going to pause for just a second. So here's the question that they gave us in the 4.1 checkup for number 6. And again, it's what I'm always doing in these sessions is I'm sort of refreshing what you should have already learned in that section for 4.1. So I'm not reteaching the entire section. I'm just touching on the key pieces that I want to make sure you guys don't miss. So that's why I'm always teaching on it the next week after you've done it, because I'm expecting you to have tried it on your own, and then I sort of fill in the gaps for you. So number 6 says tangent squared x minus sine squared x equals tan squared x times sine squared x. It's telling us to start with the left-hand side, so I'm going to underline the left-hand side. So the first thing that we're going to do, one of the hints that it gave us in the online lesson, it told us to always try and put things in terms of sine and cosine. So we're going to break down this tangent squared theta. And I'm going to rewrite that as sine squared x. Okay, great, Nicole. Cosine squared x And then we'll drop down our minus sine squared x. And the reason being over here is because it follows the definition that tan equals sine divided by cosine. So I'm just replacing tangent, changing it into all sines and cosines. Now, the next thing that we want to do is we always have to have common denominators, because if I'm subtracting, we know that I'm not allowed to subtract these two terms until I have a common denominator. So in this first step, I know it doesn't also say get common denominators, but that would probably also be one of my reasonings as well, is to get common denominators. So I'm going to make both of them have a denominator, oops, let me erase that, of cosine squared x. So since the first one already has a cosine squared x, it can just stay just as it was. Now this next one, in order to have a cosine squared x on the bottom, I'm also going to have to put a cosine squared x on the top. Okay, so my first two steps that I did is I replaced my tangent with sine over cosine, and then I'm also going to put that I got common denominators. Okay, so the next step that they're telling us the reason is this follows from factoring out sine squared x. So they're kind of telling us what to do next here. They're saying, look at my light blue problem, and on the top I do have a like term. I have a sine squared x, so I'm going to factor that out in front. So sine squared x. So if I factor out a sine squared x, I'm going to have 1 minus cosine squared x. All of that is over cosine squared x. Okay, the next thing that they do, and I wish I gave myself a little more space here, is they're going to put this cosine squared x under each part individually. So they're going to put it under this first part individually and this next part individually. Let me change colors here. And I'm going to show you why they do that in a minute. So again, I pulled out my sine squared x. So now I'm going to write this as 1 over cosine squared x minus, if I put these two under each other, I'm just going to get a 1. So see what I'm doing? I'm just doing like my V. I'm just putting it under each portion individually. So now my next reason over here is it says this follows by the definition of secant x equals 1 over cosine x. So what they're talking about there is this portion. The 1 over cosine x can become secant. So let's change it. So out in front I have sine squared x. This is going to become secant squared x minus 1. Almost done. If we look at our Pythagorean identity, if we look on our chart that I passed out to you guys, one of them has a secant in it. It looks like this right now. It says 1 plus tangent squared x equals secant squared x. That's almost this right here. All they did was they moved the 1 over. So my new trig identity now says tangent squared x equals secant squared x minus 1. Are you okay with how I just took the 1 and I just moved it to the other side? I just subtracted the 1. So now I can replace secant squared x, this portion, secant squared x minus 1, with tangent squared x. So I have sine squared x out in front, and this whole parenthesis became tangent squared x. Well, this is exactly what I was trying to prove was the right side. Man, I don't know what is up with Illuminate, but I get kicked out quite a few times during each session. It's really annoying. Sorry about that. So our whole purpose when they give us the reason is to look at the reason and then see what kind of work would buffer that reason. What kind of work would buffer that reason. By the time we're done, if we start with the left side should look just like the right side. So this next time, I'm going to give you all the calculations, but I want us to fill in the reasons. So let's try this one. This is number 10 on your checkup. And some of you guys have already turned these in, which is fine, but it's always a good idea to check your steps anyway. So this time it's telling me secant x plus sine x times cotangent x equals cosecant x plus cosine x. Okay, so when I'm looking at my first step here and I'm trying to figure out, hey, what happened from here, because here is my original. Here's my original right here. How did they go from here to here? Well, they changed from secant to 1 over cosine. Why am I allowed to do that? So remember, one of the rules when we start doing proofs is we want to get everything in terms of sine and cosine. So if I see a secant, I don't like secant. If I see a cotangent, I don't like cotangent. So I want to change everything that's not a sine or cosine into a sine or cosine. So when I see a secant, I know, hey, secant is actually 1 over cosine. How do I know that? It's actually the definition. So you can say it's the definition of secant equals 1 over cosine. Are you okay with that first part? How secant became 1 over cosine? The reason is it's just the actual definition. Okay, then they left the plus sine x. They left plus sine x. But then they changed cotangent. They changed cotangent to cosine x over sine x. Now why did they do that? Or what's the reasoning? Because again, it's the definition of cotangent. Cotangent equals cosine over sine. If you have your chart, your trig identities chart, that's under the quotient identity. Okay, so not only, you could say definition, or you could say that that's the quotient identity. Either way, either one is accurate. Questions so far about step 1, about our reasoning? Okay, so step 2, how did they get from step number 1 to step number 2? So we have to ask ourselves, what's going on here? Well, it's hard to see when they are side by side, but really what they're doing is they're simplifying by multiplying through cosine x over sine x and canceling the terms. So right here, they're multiplying through cosine x over sine x. Because think about what this really is saying. If I had a lot of space and I was really doing it correctly, let me go back to black for a minute. If here's what I have, let me give myself some room. I hate trying to cram all my work into like a little teeny space. If I had 1 over cosine x plus sine x, that's times cosine x over sine x. This is what this says. I just wrote it up and down from each other. So what they're going to do is they're going to take your cosine x over sine x and they're really distributing it. They're multiplying it times the first term and they're multiplying it times the second term. So what's our reason for the second one on how they got from step 1 to step 2? You could say that they distributed cosine x over sine x. You could say that they simplified. There's lots of correct answers. Simplified, canceled terms. There's a lot of different ways to say the same thing, and I would accept all of them on a test or quiz. They would all be correct. And then lastly, how did they go from this step down to the last step? Well, 1 over sine is the same as cosecant. Why am I allowed to say that? Because it's the definition of cosecant equals 1 over sine. So sometimes I'm going to give you the left side and ask you to fill in the right. Sometimes I'm going to give you the right and ask you to fill in the left. And sometimes they don't give you either one. So let's do one where they don't give us either one. So let's sort of remember our rules to ourselves. Our first step is always to get anything that's not sine or cosine, change them into sine or cosine. That's always going to be our first step. So let's try this one. So when we first start a proving problem, when I'm trying to prove that the identities are true, we always are going to start with the harder of the two sides. So if I'm looking at this problem, the side that looks harder than the other side would be the left side. So I'm going to pick the left because it looks harder. Now what's my first step going to be? To change anything that's not sine or cosine into sine or cosine. So let's see where we're starting. Secant over tangent. Okay, so let's look on our trig identity chart. Secant. What can I change secant into? Secant is the same as, lost my pen. Wow, this is such an awesome, fantastic day in Illuminate. One more time. Come on, pen. Work with us here. Ugh. Well, Miss Nicole, my pen stopped working. That's pretty awesome. Okay, there. So secant is the same as 1 over cosine x. And tangent, if I'm looking at my quotient identities, tangent is the same as sine over cosine. Man, they don't give us enough space, or I didn't leave myself enough room here. So what would my reason be? Well, it's the definition of secant, and it's the definition of tangent. Or we could say quotient identity, either one. Quotient identity, tan x equals sine over cosine. Okay, so that's step number 1. Now, what do you think I'm going to do from here? If I have this big old problem and I have this really long division bar here, I don't want to leave that division bar there. So from here, I'm going to just want to simplify. So I have 1 over cosine x. And we know that instead of division, I can change a division to multiply by the reciprocal. You okay? You with me on that one? So I can change a division to multiply by reciprocal. And my reason being over here on the other side could be simplifying. You could even say multiply by reciprocal. You could say cross cancel. You could say all kinds of things that are all correct. Good question. When they give you 4 lines, nope, you know you're not always going to use all 4 lines. I wish that were the case, but nope, they're just giving you a set amount of space, but you won't always use all 4. Good question. Because in this case, once we cross these off, we have 1 over sine x, and we know that that actually equals cosecant x, which is what we were trying to prove at the very beginning. So we didn't need all 4 lines, we only needed 3 in this case. But my justification for this last step would be that that's the definition of cosecant, that that's the same as 1 over sine. So let's kind of recap our steps here so that way we have a good, clear direction on how to start our proofs. So step number 1, you're always going to pick the harder side. Always. Number 2, you're going to change everything into sine or cosine. And then from there you just have to simplify using math. So sometimes you might have to distribute, sometimes you might have to get a common denominator. Your step 3 is going to look different based on the scenario that you're given. But at least that's a good number 1 and 2 to get you guys going on setting up your problems. Can I get a smiley face if that makes sense? Okay, fabulous. Okay, let's skip that one. We'll come back if we have time. Oh yeah, we're almost done actually. So to prove something that is not an identity, to prove that it is not an identity, those are actually easier. You only need to find one counterexample to prove that something is not true. Kind of cool. So if I said, yeah, I can't think of one off the top of my head. But anyway, it's like if I told you that walls are always flat. Well, to prove that that's not true, you could point out one wall that is not flat to prove that what I said is not true. So anyway, counterexamples, you only need to find one. So if we're proving an identity, it has to work for all cases, all. To prove that it's not an identity, you just need one example of how it's not true, not correct. Oh wow, no wonder I thought we had tons more to go. I had a lot of blank slides in there. So let me remind you of our week 11 essential question, and then I will go back and do that one final example if you want to work through it with me. So our week 11 essential question again is just what is the difference between an identity and an equation? And that answer will go in the week 11 Dropbox. Okay, so I will now go back. We'll do one more proof together and we'll call it a day. If you're feeling comfortable, you can go now, but if you want to do one more, then hang out and we'll do one more. Okay, so this was number 16 on 4.1. And our question said secant x plus tangent x times 1 minus sine x divided by cosine x equals 1. Well, in this case, I definitely have a more complicated side than the other side. In this case, my left-hand side certainly looks way more daunting than my right side. So I'm going to choose the left side to start with. Plus, how are you going to prove that 1 equals all of that? How would you start with the right? You can't. You can't start with the simpler side. You've got to start with the more complex side. Okay, so step number 1. Change everything that is not sine or cosine into sine or cosine. So let's start there. So secant, how can I rewrite secant? If I look at my trig identities, secant is the same as 1 over cosine. How can I rewrite tangent? Tangent is the same as, oh, they don't even do it that way this time. That's not very nice. They totally do this one a different way. All right, well, let's try it their way, and we'll see. We'll see what we think. Okay, so what they did was they left secant and tangent alone, and they dealt with their fractions first. So how can I rewrite 1 over sine? 1 minus sine x divided by cosine x. What they did with this portion over cosine x. So right now it looks like this. The first thing they tried to do is get rid of their fractions. So that was what they did first. So let's do that first, because it is going to actually make it easier on us if we get rid of our fractions first. So if I put my cosine under each part individually, I still have secant x, tangent x out in front here. So now let's write 1 over cosine x can be rewritten as secant x, and sine over cosine can be written as tangent x. Okay, so I guess when we wrote down our man, oh man, that's annoying. I'm sorry about that. So when we wrote down all of our steps in here, pick the harder side. In here somewhere, I guess we could have added get rid of fractions, because if we can get rid of fractions first before we change things to sine and cosine, it is going to simplify our life. So we could probably put this step in here as really our step number 2, but maybe do a question mark because we don't always have fractions. So I should have probably added that step in for us there. So let's kind of take a peek back at where we are. So I've changed my 1 over cosine into secant, my sine over cosine into tangent. Now, before I go any further, because normally at this point we would say, hey, let's make it all sine and cosine. Before I go any further though, let's think about this. This is 2 terms times 2 terms, right? This is like this. If I had an x minus 1 times an x plus 1. My first term is the same, right? I have an x and an x. My second term is almost the same, but one's a positive, one's a negative. Do we remember if I have 2 terms times 2 terms, what would I do to simplify that? Do we know? What would I have to do to simplify this problem on the right if I'm doing the shortcut method? This kind of goes back from Algebra 2. It's been a long time. Yes, we'd have to distribute. And this is actually a FOIL problem where we do our first term, our outside term, our inside term, and our last term. Watch what's going to happen when we do that here, because I have 2 terms times 2 terms. So I'm going to get secant times secant, which is going to give me secant squared x. I have a secant minus a tangent, so a positive times a negative will give me negative secant x tangent x. In the middle here, I have a positive times a positive, so that's going to give me a positive, and I'm still going to write secant first, so secant x tangent x. And then lastly, tangent times tangent, so a positive times a negative will be a negative, and tangent times tangent will be tangent squared x. So look at this middle term here. I get a minus secant squared, or minus secant x tangent x plus secant x tangent x. A minus and a positive cancel each other out, because it's like saying 1 minus 1. They go away. So now I have secant x minus tangent x. And if we look at our trig identities, secant squared x, tangent squared x gives us 1, which is what we were trying to prove. That is just a crazy problem. No wonder they had that in the session for me to do with you guys today. So let's go through our right-hand side and how we would justify these steps, just making sure that we know what to write over here. So let's grab my pen. So our first step, we just sort of simplified. We put our cosine squared x under each part. So we could say that we simplified our fractions. Then what did we do on this next step? We FOILed, or we distributed. Here we combined some like terms. And then lastly, my proof for this one is that that is actually your Pythagorean identity. So looking back at our steps one more time on the slide before this, we're always going to pick our harder side first. Sometimes we're going to have fractions that we're going to get rid of, but most of the time we're going to do number 2. I say most. Let's say like 99% of the time we're going to do number 2, which is change everything from sine to cosine and then simplify. So in this problem that we just did, we did not have to do step number 2. It's that crazy 1% because we had to do this extra step first, which was to get rid of fractions. So honestly, the best way to start these is just to keep your trig identity sheet handy, walk through these steps, and ask yourself, what can I continue to do to simplify my problem? And it just takes practice, but you guys will get good at them. All right, well, thanks for joining me today for a review of 4.1. Next week, we will jump in with 4.2 and possibly the beginning of 4.3. But I hope that you guys have a great week.